Thank you so much, Marcus. It is a pleasure to be here at the Selenium conference with you all. And I'd like to just give you guys my details in case you want to keep in touch. I'm a senior engineering manager at Uber, and I'm hiring, if anyone's interested. Email, LinkedIn, Twitter. And I'm really excited to be here, actually. There's a lot of really great things happening in the Selenium domain and ecosystem. And it's really great to see this technology that was totally disruptive at the time when it came out 10, 15 years ago, continue to thrive and grow. And I think a big part of what we're going to see in the future with Selenium testing in the next 2 to 5 years is going to be kind of more specialized testing, standing on top of the shoulders of Selenium, where Selenium is sort of providing the skeleton framework to be able to navigate through the application in a reusable, maintainable way, and allow us to sort of do contextual testing, so we can sort of flip a switch and say, we're really interested in doing visual testing for this particular run, so we're going to use Apply tools right now, and that's going to be taking screenshots of all of the different views that we come across in our navigation suite. But the next run, we're actually really interested in performance testing. So this time, we're going to change the context and start collecting metrics on how quickly we're getting responses back and how quickly the app is responding. But we're still using the same Selenium code to navigate through the application. We're just reusing it in a different context. And so I think we'll start to see a lot of this sort of functional testing paradigm start to take over as people really realize that there are lots of ways that we're interested in testing the application. Not just functional testing, but all of these other kinds, localization testing, et cetera. So I just recently switched to a focus in security, actually, at Uber. So I manage teams of developers that work on writing software that is of particular interest to security. And so one thing that we're definitely going to set up is running Selenium with static analysis and security testing. So that's another example. But anyway, the focus of this talk actually is a little bit different. What I'd like to talk about here is not the things that are going to kind of ride on the shoulders of Selenium, but the things that will power it from below. And this is a fundamental part of, I think, what makes a successful Selenium deployment or breaks it. And it's an area that I've actually been working on a lot. It's been a focus for me for at least 6 years in my previous 2 companies, is building reliable, fast infrastructure that can power large Selenium deployments. So essentially continuous integration. So, and that's really what we're talking about when we're talking about Selenium and test automation, is continuous integration. And so what is it? It's the platforms, tools, and process that power how changes move from the developer to the customer. And essentially, it's build, test, and deploy. So I really think that we're going to start to see changes in this area, and these changes are going to be a fundamental kind of growth that is going to allow Selenium to really be embraced and deployed by the mainstream. We've seen tremendous growth with the technology in lots of companies, but we're still not there yet. There's still a lot of pain and friction and problems that people have getting test automation to work, in large part because of the unstable continuous integration platform that Selenium is running on. And so in order to see, I think, the vision of, where we'll be with continuous integration tooling and integrations with Selenium, I'd like to look at some of the elite companies that are already functioning in a kind of ideal way and compare them to what I'm calling the majority. So compare the elite with the majority. Okay. So the majority of companies today who are executing any kind of continuous integration or Selenium testing at all see infrastructure as something that is trivial, it's low priority, it's easy to maintain, it's non-integral to the business, it's non-impactful to the bottom line, and over time it's equally important. The minority of companies that are doing things the right way right now see infrastructure as the highest priority. At Uber, all of our most talented engineers work on infrastructure. They see it as something that's extremely challenging. Minimally, it's a distributed system. In its best implementation, it's a distributed information retrieval system. It has a direct and immediate impact on the business bottom line. And its impact grows exponentially over time. So if you neglect it, it will exponentially cost your business as time passes. And if you invest in it, it will exponentially pay dividends back. So the majority of companies today staff with junior people for this domain, either with no one and they'll do it later, with an intern, outsourced with a junior developer. The minority elite use senior staff. It's the first job of the first hire. The most talented, powerful engineers work on it. The senior architects are involved in making sure that it works properly. The majority see this work as being trivial, as being kind of scripting. It's a workflow problem. And the minority see it as a deep problem, a real computer science, serious computer science problem, graph theory. It's essentially reevaluations of a directed acyclic graph where source, build, and test code are vertices and dependencies are edges. The majority of companies view releases as things that are pulled. So when it comes time to release, we trigger a process that pulls changes through the system to create an artifact for deploy. Humans are typically in charge of this, and computers sometimes help. The elite minority see releases as things that are pushed. Changes are made that cause the graph to be retraversed, and deploy as a result of the retraversal of the graph. Computers are in charge, and only if there's an issue, which hopefully doesn't happen very often, are humans asked to intervene. The majority of companies basically do things in the least efficient way in this domain. They build, test, and deploy all the time, everything. Often inconsistencies and deltas are introduced from development to staging to production, which introduces more inefficiencies because those need to be understood and debugged. The elite minority treats this as a well-understood problem of DAG optimization that includes precision, recall, idempotent build process, where builds for development, test, and deploy are identical. The majority of companies have the following environment for their developers. It's a local file system, and there's limited capacity for CI. So there are humans who are waiting for computers to finish their work, which is the opposite of what we want. So the minority of elite companies are using a virtual file system for developers to work with this emerging technology, for example, of IDEs in your browser. And the capacity for CI is auto-scaling. So when there is a large workload and there are many jobs in the queue, compute resources are auto-scaled out. So humans aren't waiting for computers. Computers are waiting for humans. That's a key difference. The majority of companies find changes after they've been introduced into master. The minority of companies find changes before they're introduced into master, which basically means that only safe changes are allowed into master, which basically translates to all changes are tested completely before they're merged into master. And therefore, master is always stable. The majority of companies have a random process, which is varied, inconsistent, inefficient, with humans being highly involved. And the elite have a consistent process that is well understood and well known, with human involvement being very minimal. The majority of companies, Sorry, I thought I removed this. This was originally written for a smaller crowd. Basically, non-determinism is acceptable with most companies, or even straight-out failures. The elites say that any test that is non-deterministic is equivalent to a failed test and does not have the right to execute on the CI environment and pollute the results for all of the other developers. Running test code is a privilege, not a right. Sorry. And that means that you quarantine, excuse me, non-deterministic tests. Most companies have a reckless velocity. Code ships long after it's ready, before it's ready, in a state of readiness that's unknown and introduces significant risk. A lot of times changes are bundled together and they're 100% binding. Sorry. Elite companies have a responsible velocity where code ships as soon as it's ready and no later, and in a state of readiness with low risk. Thank you. Changes are shipped independently, dark launched, and A/B tested. Okay, so we have a glimpse of the future and where we want to be, what the best companies are excuse me, doing. Sorry, something in my throat. By the way, don't feel bad if you work for a majority company. We all mostly do. So, where are we now? So Selenium WebDriver is the industry standard. And we know as a community, and the world knows more and more, that real and lasting quality is built in from the beginning with continuous integration, test automation done along with development. That's a well-established fact. But we still have trouble executing successfully. Thanks. Sorry. I have lots of water here. I'm going to be very well hydrated. And I kind of assert again that it's because the platform that we're using to run continuous integration in Selenium is itself deeply kind of unstable. But I get calls from people all the time, like every week, saying things like this. We can't ship without introducing bugs. My investors are unhappy. Our velocity and quality continue to decrease. We need to implement CI, but we don't know how. I get like 2 calls a week from like small companies, big companies, medium-sized companies. No one knows what to do about this issue. But they all know that they want it, and they should have it, and they just don't know how to get it. And I think that's because of the broken continuous integration process and platform. It's not Selenium's fault. Selenium is awesome. It's how we run Selenium. So I actually did some market research. I had a gathering of about 70 build and test engineers in San Francisco. And I said, what are you guys using for your continuous integration tools to support Selenium? And every single company and person I talked to uses Jenkins, which is crazy. Mostly on AWS. I thought Jenkins was the majority. It's like the 100%, that's what everyone uses. Done. And yet no one is happy with Jenkins. Yeah, 0% of people are happy with Jenkins. All right, so why has Jenkins failed so hard, and all the challengers as well? I mean, there are other companies or open source projects trying to solve this problem. Basically, it boils down to these issues. It's too slow, it's unreliable, and that means that changes are batched. And all 3 of these things are related, actually. And there's not enough of a win for people to move from what they know Jenkins to another system. It just doesn't have a big enough improvement. So the attributes that I think we'll see, hopefully soon, around next-gen CI technologies will be fast, speed. We need near instantaneous results, and we can get there. We have the technologies, they're coming. We need to practice the not rocket science principle, which is essentially all changes are tested before entrance into master, period. We need to embrace the machine as code, cloud as code, Devops Renaissance, where our environments, our operating systems, our virtual machines, our networks are all built with code that is written down and checked into a source control system that can be revision controlled. Thank you. We need to be able to trust our results, which basically means that non-determinism is not tolerated. I think we'll start to see a lot of build and test architecture templates on how best to do things with each of the languages, product analytics. There's a huge amount of data that is not being taken seriously around build and test. And if we did take those things seriously, we could start to make huge leaps in terms of like decisions about whether the product is ready to ship, whether we're writing things correctly, et cetera. I think we'll definitely see a lot of new cutting edge technologies like we're seeing here at the conference. Not just data around, metadata around build and test, but also data around process, what processes work, what don't. And we all need to be dog fooding whatever we do. So let's dive into speed a little bit more. I think that speed with continuous integration and with Selenium is absolutely the critical factor here. If everything else was not done and we only achieved speed improvement, we would still be mostly like 90% successful in a sort of ubiquitous rollout of successful Selenium deployments at companies. And I think we'll start to see that with new technologies that are coming beyond virtual machines and containers with unikernels and essentially just smaller smaller ways of defining the process, because ultimately we're really just we're concerned with the process that's executing and the libraries that it needs. We're not concerned with running an entire operating system. We'll look back, 5 years from now and think it's crazy that we're running an entire operating system with all of the attack vectors and process consumption and size, and we didn't need to be doing that. We just need to run the process in a contained environment that cannot be shared or leaked with anything else. And so if we do that, we'll actually be able to do a lot of more parallelization, which will speed things up a lot more. And I also think that we can be doing more intelligent build and test by basically only compiling and testing the changes that were made, not the entire application. So the not rocket science principle, this is basically the foundation of CI/CD. If you're not doing this, you're not doing CI. It's basically the way I see it. The Devops Renaissance, this is really awesome. It's happening. We're seeing a bunch of amazing companies like HashiCorp delivering tools that can make this a reality out of the box. And then once we get speed and reproducibility, we can start to insist on trustworthy results. Because if we have that speed, then we can actually start running each change, every test for each change 100 times or 1,000 times, and we can know this test is non-deterministic. It needs to be quarantined right now. Or this application is non-deterministic. There's a problem with the logic here. I kind of talked a little bit about this in the beginning, but I think we'll start to see more of a functional pattern with testing rather than rewriting test flows in different languages or with different tools. I think we'll start to basically use the same code with a functional pattern of just changing the context of that run. And imagine what we could do if we actually took this data seriously. And we could say, we've done, we have like professional data scientists who've modeled the time it takes to run build and test, and we've correlated that with the JIRA bugs, and we know that these changes were made on these lines, and we can tell you what part of the product is well tested, what part of the product isn't, if we're ready to ship, at what risk we're doing. Like, we could have so much insight into this if we actually started to do real data analysis. Yeah, I think I mentioned these already, but SEML is a really interesting static analysis technology out of Oxford that I think has a lot of promise. I'm super excited about. Applitools is absolutely groundbreaking, and I highly recommend everyone checking it out. They're here at the conference. HashiCorp is another leading vendor that I've had a lot of success with, but there's plenty more out there. And we don't have to stop here. We can continue to improve our process based on the data that we collect and analyze. And of course, everyone should be dogfooding this themselves for all of the internal tools that they build. And that's the vision of Selenium testing in 2020. I hope you guys join me in the revolution for awesome change. Thank you. So with that, I guess, does anybody have any comments or questions?
You got 23 minutes. Question right here. So, in my observation, one of the barriers to continuous integration of these large monolithic legacy systems is one has small modular systems that you can change, make surgical change to individual components. But when you've got these large systems with many dependencies between different many different teams. How do you get from here to there?
That's a really good, okay. So the question is, what do you do when you're working at a company that has a large monolithic code base with lots of dependencies? How do you do that? Yes, that is an interesting question. There are different approaches you can take. One is to basically put a wall around the monolith and say that all new development happens in manageable small repos that are essentially API-based, that have to talk in to an API. And so any work that's done new is done this way with any supporting API work done in the monolith if needed. Other things you can do are sort of try and attack it from the inside, so try and pull the spaghetti apart. That's a slow process. Companies do it. A company I used to work for is doing that right now. It's possible. Usually it doesn't get the staffing and the funding required to do it in a timely manner. So by the time they're finished, it probably won't matter anymore in that sense. As far as just testing goes, though, it's worth analyzing your tests and looking at which tests are slow, which tests are fast, which tests are valuable and not valuable. Treat your test code like your production code. A lot of it should probably be deleted. I mean, the best thing you can do to your code base over time is actually remove code. Try to delete your tests. Try to refactor your tests to be more meaningful, and really only assert the most critical things in the most concise, efficient way. Use mock APIs for systems that maybe require a monolith, but that aren't required for testing a different component that you're writing, et cetera. Cool. Any other questions?
So the question I have is, how do you deal with people who don't think in pipelines? And how do you, because sometimes people say, you have to think in terms of pipelines. You have to deal with things, well, putting words in your mouth, but sometimes I'm having trouble with explaining to people CI and pipelines is really the first class citizen in terms of building it. I'm curious as how, when you meet people and you talk to them and you see that they really don't think this way, how are you trying to explain it to them what to do next?
I mean, most of the people I talk to, companies in the Bay Area, technology companies in the Bay Area, they understand that CI is really important, but they just don't know how to do it. And they understand that Selenium has a lot of promise and can add a lot of value, but they just have never been able to make it work for them. So I'm typically not talking to people that question the validity of the goal, but more so just the practical implementation and how to. I think that was probably the case though. In fact, let me see if I can remember a time when that was the case in my career. That's definitely been the case in my career in the early days when I was writing web applications for Walmart.com in the late 90s, and that was pretty funny because we didn't have any idea what a unit test was or anything like that, and we would basically ship changes and production would break and we'd fix them, and it was all very unstable all the time, and it took forever. And the process of writing software was just extremely long, because you'd sit and write the code, and then you'd test it, and you'd find bugs, and then you'd fix the bugs, and then you'd give it to QA. QA would test it, they'd find more bugs, and you'd fix those, you'd push it to production, there'd be more bugs, you fix those, then there's a regression, you have to fix those, and it was just the life cycle of feature development was just incredibly costly and inefficient. And if I had to explain to those people then why CI is so important, I think I'd just focus on the efficiency angle. Just like any other part of the business, if the way that you're operating your business is morbidly inefficient, that's going to have a huge impact on whether or not the business succeeds, if it's profitable or not, and try and find metrics that show time. Time is a big one, and cost as far as developer cost, just in terms of salary. That will generate some very high numbers. And then you can also include lost opportunity costs. So not only are you losing money with highly paid engineering workers who are doing something that's extremely inefficient, but you're also losing the opportunity that they could be working on something else that's actually profitable for the business. So that's typically how I focus on selling large purchases for things supporting continuous integration or test automation is with those numbers.
I'm interested in knowing a little more about the common gripes with Jenkins. We all are pretty much I'm using it too. And I'm just wondering where this fits into your vision of where things will be.
So, probably I'm not being totally fair to Jenkins. So I think Jenkins is fine for small teams, small projects, small number of commits happening each day. It does the job, it's okay. Where you get into problems with Jenkins is when you're trying to scale it. And typically anyone who uses Jenkins who is successful will inevitably run into these issues. And I've actually talked at length to certain companies that are commercially selling Jenkins. And what I've asked them is you guys must have some way of, some software that manages Jenkins at scale and makes it be able to auto scale worker nodes, in a reliable way. And the answer I've gotten is well, we can send a team of humans, professional service humans, to come on site and manage it for you. I'm well, I really don't want humans. I want computers to manage my computers. But Jenkins, it was written 20 years ago. It's very old technology. It's not. No one's rewriting it for the needs, which today are essentially scale, horizontally, parallelization, highly redundant, reconstructible type stuff. So, yeah. Yeah. Yeah, cool. So the idea behind that is basically, we have a lot of potential in our Selenium tests right now as they stand. We could probably be harvesting a lot more value from the Selenium tests that we currently have than we are. Because the beauty of Selenium is that it's actually running on like a fully functioning stack, the entire application normally, with everything running in a realistic way in an actual browser. And so what we can do is we can sort of take two approaches. We can implicitly change context, or we can explicitly change context. So an implicit example would be, essentially, I have my page objects and I have my test, and my test is checking login, the login flow. And I decide, I have a few tests testing login. I have one that's testing an invalid username and password, one that's testing a valid username and password. And I decide that it's really important to me that for certain runs, when I specify, basically with like an environment variable that I set, I want to do visual testing for the page that says, an error message when the login's incorrect. And so I say, my environment variable for applitools context, I change that to true, and I run the test. And inside my test code, I have essentially a call that says, check context or assert context. And that function might say something like, if applitools context is equal to true, make a call directly on the applitools API at this point, right as the error message is showing up in the invalid login flow. So that would be like implicit testing, and I could maybe change that function to say, kind of a switch statement or something like applitools context, else if, or and if, performance context, and if security context, and each of those would trigger a specific call into another system that's doing validation. So that's sort of explicit. Did I say? I meant explicit testing, but we could also do implicit testing, where basically we just say implicitly for every single view that this flow is generating, I'm going to send each view to applitools, regardless, because that's what I'm interested in. Or every request that we're making, I'm actually going to measure that and store that in a database so I can compare the performance of the application with the previous run. So there's sort of two ways of doing it. There's actually some pretty good examples of this in Java that I can send out and share with you guys, and done in a less kind of kludgy way. The way I'm describing is a little bit simplistic, but there are, I think, more elegant ways to kind of achieve the same thing, which is basically, depending on what you're interested in at the time, you can trigger specific validation across the same Selenium flows. Does that make sense? Did I answer your question? Yeah, okay. And yeah, come find me and I can share some code that does that really well. Yeah, I mean, those developers will kind of reap what they sow. Like, I mean, so one of the things that I love about working at Uber is we do a lot of things really well. Some things we're still working on and improving, but we've done a lot of really good things there in terms of we have everything set up as like microservices, so we have thousands of little Git repos that all basically deal with like RESTful API. specialties, and each of those code bases is like heavily unit tested and API tested. And we do constant deployments to production with each team basically can deploy at any time when they feel like it's ready. But if it breaks in production, they fix it. So everybody is on call for their own code. So if they decide that they want to basically take on a huge amount of credit card debt with their code, and then they want to pay it later, like in the middle of the night, exponential, like, or whatever, huge increased dividends of technical debt later, that's kind of their decision. So it's like this feedback loop. I find that developers that don't see the value in like test automation typically aren't responsible for dealing with bugs that they introduce in production. And so, anyway, yeah, that's, I mean, I don't know, come find me privately and we'll brainstorm. It's also true that, like, you know, the company culture can kind of have a big impact on this. Like, if developers feel that they're under huge pressure and deadline to ship things quickly, you know, and they'll try and cut corners to get things done, that can definitely happen. And the trick there is basically finding like senior developers and architects and people, and this is really the thing I think that differentiates senior engineers with junior engineers, is like people that have the courage to basically push back and say, you know what, I know that we have this deadline, but we really need to take another half day or, you know, day to add unit tests or testing, and can do it in a way that makes sense to the business and can sort of convince the business to invest in that. And if they do that well, can gain credibility and sort of lead the engineering group into the right direction. But it's challenging. Like, it's definitely not easy. But yeah, we can brainstorm more if you want. So. Yeah, and I think that's definitely an area that we're starting to see major improvements with, and sort of cutting edge work happening in DevOps. And the idea is not only is one machine something that we can represent with code, but an entire cloud of machines is something that we can represent with code. And we see that with Terraform, which is a new tool from HashiCorp. We see that with CloudFormation, which is something that Amazon offers. We see these kinds of tools emerging in other places as well. And the idea is that you have to have like an extremely consistent, almost like hermetically sealed way of duplicating complex deployments of applications and services that work with across a network that comprise the application, so that we can say, okay, we have automatically created and deployed this complex cloud here. We've done it again, duplicated it here, and we've done it again here. And we can test and see if there is a divergence. And there's a lot of really great tools out there as well to help with that. And taking the time to do that correctly will make the difference. We actually built a auto-scaling, well, semi-auto-scaling Mac, a virtualized OS X cloud with tools from HashiCorp, Console and Surf, and we were able to construct a sort of a consistent virtual cloud of OS X VMs, and we were able to detect anomalies as they happened that were related to things lower and higher on the stack. So we actually discovered an issue with some of our networking infrastructure because we had taken the time to basically assert consistent state with our VMs. And it saved us a huge amount of time, like debugging and understanding what was going on. But I think that sort of thing is still fairly new and sort of considered fairly cutting edge, and a lot of people working with DevOps sort of see it as being too much work. I don't think it is. I think it's absolutely worth it.
Earlier in your presentation, you talked about how building and testing your code can be seen as a graph traversal problem. I wanted to clarify, from my understanding, would an example of that be, say you make a change, and instead of running all of your tests, you traverse your code base somehow and figure out, I only need to run a subset of tests, which is going to be much faster.
Yep, exactly.
And then follow to that, are there any tools currently that are attempting to do something like that?
There are. So, yeah. So the question is, what do you mean by graph traversal, and are there any tools that are actually doing that or attempting to do that already? And exactly that. What I mean by graph traversal is we only compile and test the changes in the code, the code that has been changed. We don't actually recompile and retest the entire code base because it's totally inefficient. Like, that doesn't make any sense. And there are tools like this, actually. So first of all, if you use Maven correctly, for example, you can achieve the same result pretty easily. Problem is, most people don't use Maven correctly. But if you do, you can basically like modularize your code such that this sort of happens for free. But there's also things like Buck and Blazel or Blaze, things from Google and Facebook that actually Simon Stewart is, I think, highly involved in. So he would be a good person to talk to, that are basically doing just that. And a lot of them have been open sourced. So definitely worth looking at. And I absolutely think that this is how we're going to start working very soon as sort of a mainstream thing, especially for large code bases. Yeah. Okay, 2 minutes. Anybody have any final questions? Thank you guys so much. It's really an honor to be here. Thank you.